Hey, welcome back to Algebra 2. Today we're looking at 4-1 simplifying radicals part 2. So we're going to go into a little bit more complex stuff, but we should be able to carry our momentum from the other day into this one and do pretty well. So number 5 is just a FOIL, or a distributive property, right? So we're going to make sure we multiply each term here on the left side to each term on the right side. All right, so let's go ahead and do that, and then we'll work on simplifying it later. But we have 5 times 1 is 5. Then we have 5 times negative 2, or 2 square root of 5 is negative 10 square root 5. Then we'll move to the next term. 3 square root 10 times 1 is 3 square root of 10. And then the last part we got is 3 square root 10 times negative 2, so that's going to be negative 6 square root of 50. Okay, so this is by itself for now. This is by itself for now. This is by itself for now. Let's break down 50. So this would be negative 6. 50 is 25 times 2, right? And it said 25 because it's a perfect square, so 25 times 2. Everything else stays the same. And then we're going to break down 25 times 2. So 25 perfect square, right? So square root of 25 is 5. The 2 stays where it's at, right? It stays inside the radical. There's no perfect square there. So let's skip all the stuff on the left side and just simplify this. So negative 6 times 5 is negative 30 square root 2. Everything else is in there still. Let's check, do we have like terms? 5 is constant, no other constants. This one is square root 5, no other square root 5s. Square root 10, no other square root 10s. And square root 2, no other square root 2. So this is the simplified form of that. Okay, just make sure that we simplify it the best we can. All right, so this next one is rationalizing, and I'm gonna be honest, rationalizing is a little bit obsolete. Oops, this should be square root 2 on the bottom. Sorry about that. The whole deal with rationalizing is the math people, whoever they are, the people that are the masters of math that oversee math rules and stuff like that, they said we don't like to have square roots in the denominator, so we're gonna have to change it. Now, the reasoning is okay. It's from ancient times, and what the ancient people said was that, all right, I don't like this square root in the denominator, because if we think about fractions, right, what fractions mean is, let's say I have, I don't know, 1/6, right? That means I have 1 out of 6 things, or if I'm grouping, right, I have one thing to put in 6 groups, right? Or maybe if we do another example, let's say we had 6 halves, right? 6 divided by 2. I know that that means I'm putting 6 things in 2 groups, and that's good because I'm going to put 3 things in each group, and that's exactly what 6 divided by 2 means, right? 6 divided by 2 is 3, because if I'm putting 6 things in 2 groups, I have 3 things in each group. Super concrete, like not too abstract. We understand that that means groups. So notice here that these mean groups, right? The bottom part means how many groups are putting it in. So the problem with radicals groups is if I have square root 2 on the bottom, then now it doesn't really make sense. How do I put something into square root groups, right? We want the whole number to be on the bottom. Now, in our day and age of calculators and stuff like that, we could definitely figure out what this is going to be equal to, because we just punch it into our calculator and get a decimal and be happy with it. But if we're simplifying our radicals, because we're not doing it with a calculator into a decimal form, what they want us to do is make sure that our denominator is going to be a whole number and not a radical. So all that lead up into this stuff, but it's really pretty easy once you understand how to do it. So let's take our first example, square root 3 over square root 2. So I don't like this, right? I don't care about the square root 3 in the top. I'm just super concerned with the square root 2 on the bottom. So this is what I'm going to do. I'm going to multiply by square root of 2 on the bottom. But in order to balance out our fraction, what we're going to do is multiply by square root 2 on the top. So notice that square root 2 over 2 is the same thing as 1, because anything divided by itself is always 1. So we're allowed to do the same thing on the bottom as we do on the top when we're multiplying. And it's not going to change the value of our fraction. It's just going to change the look of our fraction. Okay, so step 1, we multiply by the denominator, right? On top and bottom. Now, the reason we do this is when we multiply it out, we get square root 2 times square root 2 is square root of 4. And then on top, we multiply the radicals. So square root 3 times square root 2 is square root 6. Step 2, we just need to simplify it. If we did that step correct, then this is always going to come out to be a perfect square on the bottom. Square root of 4 is 2. And then we have square root 6 on top. We can't simplify this anymore. That would be our answer. Okay, so pretty simple once you understand what to do. Okay, for problem number 7, same idea. We take our square root 7 from the denominator, multiply it to the top and bottom. Now we have square root 49 over 2 square root 7. And we know that the square root of 49 is going to be 7. We can't simplify that, so we're done. Okay, last one. This one, note here that the square root symbol is over the whole fraction. So what that means is it's the same thing as square root 5 over square root 7. So if you want to do it that way and it makes it easier for you, you can do it. But same idea here. We're multiplying by the denominator, top and bottom. So, and I guess you can skip this step where we do square root 7 times square root 7 is 49, because by now I think we realize that this is going to just be 7. And the top we get 5 times 7, which is 35. Okay, so something new, something that you're going to be expected to do from now on in all your higher level math. Anytime you have a square root in the denominator, we're going to have to rationalize it. So be aware of it and remember that it's pretty simple. You just got to multiply by the denominator, top and bottom, in order to get rid of that square root in the denominator. Okay, good job.